Hello students, welcome to our second video lesson from section 8.2. We're continuing our discussion of linear equations. In our last video we were checking coordinate points, x, y values in parentheses to see if they were solutions to an equation, and remember that just meant that they made the equation true. The math worked out on both sides of the equal sign when we plugged the values in. And in this video, we're actually going to sort of be reversing that process, and we're going to be coming up with our own solutions to a linear equation, and then we're going to put those x, y coordinate points on a graph, and we're going to be graphing linear equations in that way. Okay, so our first example is here. It says y equals 3x minus 4. Okay, and I'm going to take this equation, and I'm going to try to come up with a whole bunch of x, y coordinate points that are solutions to this equation or fit that equation, all right? And the nice thing about doing that is we can simply choose any x value that we want and then find the corresponding y value for that x value, and that will create one of our coordinate points, okay? So I'm going to organize these in this table of values here, listing out x values and y values. And each one of these rows is going to make a coordinate point for me, okay? Now, in general, I always suggest that when we choose x values to graph, we choose a couple on either side of 0, and we choose 0 as well. So my normal go-to 5x values are -2, -1, 0, 1, and 2. Okay, these 5x values I'm going to turn into coordinate point solutions to this equation, all right? And the process to do that is essentially just plugging in the value and doing math. So when x is equal to -2, my equation then says y is equal to 3 times -2 minus 4 more. So 3 times -2 is -6, right? And then minus 4 more would give me -10. So when x is -2, my y value is -10. And that creates for me one of my coordinate points, -2 for x, -10 for y. If I do the same thing with -1, I do 3 times -1, take away 4 more. Well, of course, I do my multiplying first, right? Remember, order of operations says I multiply by 3 first. That makes -3. Take away 4 more, and I get -7. So this becomes -7. If I do that with an x value of 0, I do 3 times 0 and then take away 4. 3 times 0 is 0. Take away 4 is -4, right? If I do x equals 1, I can do 3 times 1, then take away 4. 3 times 1 is 3, minus 4 more makes -1. And then if I do the same thing with x equals 2, 3 times 2, and then take away 4. 3 times 2 is 6, minus 4 makes 2, so I get 2, okay? So what I've done here is by choosing those 5x values and then plugging each one into the equation and finding a y value, I have created coordinate points. Okay, I've created these coordinate points: -2, -10, -1, -7, 0, -4, 1, -1, and 2, 2. Now I'm going to take those 5 coordinate points and I'm going to put them onto a graph, onto a coordinate grid, and I'm going to make the graph of this equation 3x minus 4, y equals 3x minus 4. It's going to be a straight line. So all of these points should go in a straight line, hopefully. When you are doing this in your homework, feel free, you can, well, I think I just gave you IXL practice, but if you ever do have to do this on paper, just make yourself a coordinate grid, you know, as nice as you can, maybe using a ruler, or print off some graph paper for yourself if you have that ability. So I'm going to put these coordinate points on my graph, and I'm going to go -2 in the x first. That's right there. -2 and -10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is all the way down here. So that's my first coordinate point right down there, -2, -10. If I go to the next one, I go -1 in the x, and I go -7 in the y, which is going to be 987 right here. Then when x is 0, I'm going to be right on that y-axis down the middle, right, when x is 0. So it's just here down 1, 2, 3, 4 to there. Okay, and then at 1, I'm just down 1, and then at 2, I'm up at 2. So now if I take my straight line tool and I just connect these points, okay, that is the graph of this equation. Okay, so y equals -3x minus 4. I have graphed it here, and what this is doing, you guys, what this line is doing is it's showing me every single solution to this equation, every single x and y value for this particular equation. Okay, so for example, if I go to 1, 2, 3, I'm up here, right? So when x is 3, I see that my y value would need to be 1, 2, 3, 4, 5. Okay, so 3, 5 would be a solution. I could find infinitely many more solutions, right? All of these points, this point right here, this point right here, this one way up here, this one way down here, these are all solutions to this particular equation. So what the graph does, when I plot a few points and I connect them in that straight line, it shows me this is all of the solutions to this particular linear equation, right? Like I said, for today, we're just going to do this by making a table of values, by creating coordinate points that we know work in this equation, all right? Now, there are a couple other types of linear equations that we need to be able to graph, and they're slightly different, but in some ways slightly easier once we get the hang of it, okay? So we're going to start with this linear equation here, which says y equals -2, right? And I might move some things around here just to make life a little bit easier. Do this, there we go. So this equation says y equals -2. What you'll notice here is there is no x variable in the equation, okay? So even when I choose my regular 5x values, -2, -1, 0, 1, 2, it doesn't matter what my x value is, right? Because what does the equation say about the y value? It says the y value is -2. Does it matter what the x value is? No, because there's nowhere to plug that x value in and do any math. So regardless of what the x value is, okay, no matter what the x value is, the y value is always -2, -2, -2, -2, -2. The y value is always -2 for every single x value ever that has existed. So if I take some of these points and then I plot them on my graph, I plot a point here and here and here and here and here. And what do we notice about those 5 points? Well, they're all in a straight line, obviously, because it is a linear equation. But not only that, it's a horizontal line that goes right along one of my coordinate grid lines, right? So it's a perfectly horizontal line because the y value, I should say, the up and down value never changes. It's always -2. So anytime you see an equation that says y equals a number, it's going to be a horizontal line at whatever that y coordinate, whatever that y value is, all right? So if we had, let's say, y equals 7. Y equals 7 would be a horizontal line up at 7 on my y-axis. 1, 2, 3, 4, 5, 6, 7 up. And then I would go this way forever, and I would go this way forever. Okay, horizontal line, that's not perfectly horizontal, but that's the general idea, okay? No matter what the value is, if it just says y equals, it's going to be a horizontal line. Now, in a similar fashion, if we have an equation that says this one says x equals 4, now the thing that's not changing is my x variable, right? So my x variable is never changing. It's always equal to 4. Okay, so it doesn't really matter what the rest of my coordinate point is. I can have 4 as my x value and anything as my y value, okay? So x equals 4, the table of values ends up looking like this. Okay, so the x value is always 4. 4, 4, 4, 4, 4. And then I can put whatever points you want here. I can go 1, 2, 3, 4, 5. And those are all perfectly fine coordinate points for this equation because the x value is equal to 4. X is equal to 4. So if I plot these points, 1, 2, 3, 4, I've got this point, this point, this point, this point, this point. These points, notice when I connect them with my straight line, it is a perfectly vertical line at the x value of 4. Okay, so I'm going to try to get that a little more down the center. There we go. X value of 4, vertical line, because all of these points, infinitely many of them going up and down, all have that x value of 4, which is what I wanted originally in my equation, right? X equal to 4. So anytime you have an x value equals something, right? If your equation simply says x equals this, and they want you to plot it in a coordinate grid, it's going to be a vertical line at whatever that x value is. All right, so just another example for you. When you graph the equation x equals -5, we simply have to go to x equals -5. So on my x-axis, I go to 1, 2, 3, 4, 5, and I draw a vertical line. Straight up, straight down. Okay, draw a vertical line at x equals -5. So the equations that only have one variable in them, when we plot them in a coordinate grid, it's either a vertical line if it's x equals or a horizontal line if it's y equals. Okay, the equations that still have those two variables in them, like this one, we have to do a little bit of math. We have to pick x values, plug them in, find the y values, those are our points, and we will plot those on our graph. All right? If you have any questions about graphing these linear equations by creating coordinate points for them or a table of values, please do reach out to me and let me know. Otherwise, that's all I have for you right now, and we'll talk to you soon.